Welcome to The Explainer. Today, we're taking something that is usually a massive headache, water emergencies, and transforming it into an absolutely fascinating exploration of building science. We're using Short Pump, Virginia as our real-world testing ground. You know the panic a leak causes, right? Well, today we're stripping all that stress away to look at exactly how water behaves in the built environment. We are literally uncovering the hidden science of restoration.
So what really happens behind your walls when a pipe bursts? Asking that instantly shifts us from thinking about, boring home maintenance to solving a full-blown investigative mystery about hidden damage. Because what your eyes can't see is often the biggest threat to your property. It's not just a puddle on the floor. It's a dynamic, highly destructive physical process happening entirely out of sight. Here's our roadmap for today's explainer. We'll start with local threats and water risks, move into the ticking mold clock, look at categories of water contamination, break down the science of drying, and wrap up with the complete restoration process. Kicking things off with Section 1, Local Threats and Water Risks. Let's see how local geography and architecture actually dictate the way water attacks a property. Water damage presents very differently depending on exactly where and how a house is built. Take our short pump testing ground, for example. High humidity from May through September creates the absolute perfect storm for secondary damage. Then you've got older neighborhoods near Three Chopped Road dealing with historic cast iron pipe corrosion and groundwater seepage. Meanwhile, newer builds face sudden catastrophic supply line bursts behind finished walls. And we can't forget Mother Nature. When temps drop below freezing, winter freeze-thaw cycles relentlessly attack plumbing and uninsulated crawl spaces, while tropical systems can push moisture up from the coast and cause Swift Creek to flood. It's really a masterclass in how environment dictates risk. Now, there is a stark contrast between the puddle you can just easily mop up and the invisible threats hiding inside your ceiling assemblies. Picture this: a supply line fails, and pressurized water starts spraying into wall cavities. Your eyes might just see a wet spot on the carpet, right? But behind that drywall, capillary action is literally pulling water upward, defying gravity. Insulation gets totally soggy and completely loses its thermal properties, while baseboards swell from the inside out. The visual damage you see is, for sure, just the tip of the iceberg. That brings us to Section 2, the ticking mold clock. Let's see how all this hidden moisture sets off a biological time bomb inside your home. The absolutely crucial takeaway here is this specific number: 48. You have exactly 48 hours before mold colonization aggressively begins in a high humidity environment. And guys, this isn't some rough estimate. It's a strict biological deadline. If extraction and drying don't kick off immediately, all that trapped water we just talked about, it's going to start feeding microbial growth. So how do we beat that ticking clock? Professionals initiate a rigorous timeline tracking equilibrium moisture content. Basically, that just means making sure the building materials match the natural dryness of the room. Day 1 is all about emergency extraction, using these massive truck-mounted units that can suck out hundreds of gallons an hour. Day 2 pivots to setting up commercial-grade equipment and dehumidification. Then, days 3 through 6 are dedicated to meticulous, daily moisture monitoring. These experts aren't just guessing. They're measuring the materials to ensure they hit specific scientific benchmarks. By day 7, under optimal conditions, structural drying is completely verified. Moving on to Section 3, categories of water contamination. Before any of that drying can happen, we have to classify the enemy using the strict IICRC S500, which is essentially the gold standard rulebook for the industry. Now, it is absolutely vital to know that a Category 1 clean water leak can rapidly degrade into a hazardous Category 2 or 3 situation if you leave it untreated for too long. Category 1 originates from sanitary sources, like a freshwater pipe bursting. But remember, water is a universal solvent. As it sits there, it gathers contaminants, so it turns into Category 2, gray water, maybe from a washing machine discharge, which can cause discomfort or sickness. And then there's Category 3. This is grossly contaminated black water, like a sewage backup or groundwater flooding that's come into contact with soil or waste materials. The category literally dictates the entire scientific response. All right, Section 4, the science of drying. Let's dive into the actual physics of how you pull moisture out of a solid wall without having to tear the whole house down. This right here is the core science at play. We aren't just randomly blowing air around. We are mechanically altering the environment's relative humidity to pull trapped water out of dense materials like plaster and concrete. Think about it. Water naturally wants to find a balance.
So by making the air inside the room extremely dry, we create a literal vacuum effect, a vapor pressure differential. This yanks the moisture out of the wood framing and the drywall directly into the air where our equipment can capture it. It's actually pretty brilliant. By meticulously following these exact steps, professionals accelerate evaporation and continuously replace saturated air with dry air until the wood framing reaches a safe 15% moisture content. It's an aggressive combination of tactics. First, you lower the relative humidity below 50% using commercial dehumidifiers. Then, you blast that dry air across the wet surfaces at incredibly high speeds. We're talking 300 to 400 feet per minute. In the monitoring in Step 4, that's where we see exactly how different materials react. For instance, nailed-down hardwood flooring might actually be saved if the cupping is under 2 millimeters, but laminate flooring with an MDF core, it just swells up and has to be completely replaced. It's pure physics interacting with material science. Finally, we've reached Section 5, the complete restoration process. Let's see how the chemistry of structural drying transitions back into the art of construction. It's fascinating to note that because any reconstruction must meet the current International Residential Code, older properties often receive upgraded safety measures during the rebuild process. Once the drying is finished, we aren't just putting back the old, outdated materials. If an older home and short pump requires new foundation work or subflooring after a flood, it has to be brought completely up to modern standards. That means installing proper vapor retarders in crawl spaces or adjusting flood elevation requirements. It effectively makes the home way more resilient against the next storm than it ever was before. So, the big takeaway here is that true restoration is a seamlessly coordinated scientific protocol. It manages everything from the initial extraction and standard XM8 insurance billing, all the way to that final coat of paint. It is a massive, multi-tiered operation. You've got technicians verifying moisture vapor emission rates in concrete slabs, directly transitioning to project managers who are coordinating electricians, plumbers, and drywall installers. And they're all speaking the exact technical language required by insurance adjusters to ensure everything is covered, ultimately delivering a completely restored environment. I want to leave you with this final thought to consider about your own property's vulnerabilities. If a supply line failed behind your walls today, how prepared is your home to fight the unseen damage? I really encourage you to look at your home's hidden infrastructure with a completely new scientific perspective. We've explored the geography, the biology of mold, the rigorous physics of drying, and the standards of reconstruction. Now that you understand the hidden science of water restoration, you know exactly what is at stake the next time you spot a seemingly harmless puddle on your hardwood floor. Thanks for exploring this source material with me on today's Explainer. Keep your environment dry and keep learning.